Okay, yeah, so thank you, and let me start to talk about my journey to Kaggle #1. So maybe a quick introduction of what I want to do today is I want to mostly give you rather an overview of where I started and where I'm currently now, of what kind of competitions I did. I want to talk specifically about a few of them, and I want to mostly focus on the learnings throughout the journey. I will not go too much into detail about certain methodological aspects. So if there are questions on some of these topics, we can maybe cover them also at the end. But I rather want to give a broad overview of what I have encountered on Kaggle, and talk about the journey. So I guess I can skip this slide, but sometimes there are people in the audience who have not heard of Kaggle, and it's kind of my task also to bring Kaggle to others. So Kaggle is your home for data science. It is an online community of data scientists and machine learners. It was originally founded in 2010 and acquired by Google actually in 2017. It is mostly well known for the data science competitions. That's how it started, and that's what we will talk about today. But it is also a whole community with discussions, courses, tutorials, and also a whole infrastructure for notebooks. And it also has a built-in free infrastructure for CPUs and GPUs, similar to Google Colab, for example. So who am I? Already got a short introduction, but yeah, my name is Philipp Singer. I live in Vienna, Austria. I'm also born in Austria. I hold a Ph.D. in computer science, and I also did a short postdoc in Germany. My PhD and research was rather in the area of web analytics, web data with more of a statistical touch. And I only really got into machine learning a little bit later, but of course it was also part of my previous scientific endeavors. Yeah, I have profound experience in ML research and applications, and currently what we want to talk about today is my journey on Kaggle that has allowed me to achieve, at least for a short time, rank first on the global leaderboard. I work as a senior data scientist at H2O. Some Kagglers might know the company. We employ several of the top Kagglers, and also we have open source software that you might know. And yeah, we try to democratize AI. We have a similar mission, and yeah, we focus on AutoML and app development. But let's get back to Kaggle. So this is kind of my trophy collection, where I want to talk about some of the aspects of this trophy collection today. Yeah, so want to talk about how I managed to reach Kaggle #1. The left screenshot is one that I directly took after I managed to grab the first position. You can see that the top global leaderboard rankings are quite crowded at the moment. This has not been the case always. Like there was sometimes sometimes kind of a competition between two people, but now it is rather a competition between 4 people, and it can quickly go that someone from below is jumping up. So the difference is really just 1 or 2 competitions, and this might change a lot in the near future. But this also means the kind of competition is very, very tough at the moment, and very also encouraging. On the right-hand side, you can see my profile. I have participated in like quite a few competitions. I have achieved 17 gold medals, and I have actually won 6 competitions. You can see that, yeah, I mostly focus on competitions, not so much on data sets and notebooks, but I also like to talk a lot. So I'm quite active on the forums, and yeah, I try to share a lot of the stuff I have been doing. So also if you're interested in some more technical aspects of some of the solutions I present, I would encourage you to go to my profile, browse through my previous competitions, and usually we always post quite detailed solution summaries. So let me start with my journey, which actually began 9 years ago, but not really. So 9 years ago, it was quite at the beginning of my PhD. Apparently, I heard somewhere about Kaggle, and I started to create a Kaggle profile with my Google account, and started to make a test submission to this Facebook recruiting competition. And as far as I remember, I probably just imported scikit-learn, loaded the CSV, and maybe fitted an algorithm on the full data and like made one test submission. I probably spent 1 or 2 hours on it, made a submission, ended up in 257th spot and forgot about it. So what were my first learnings on Kaggle? Maybe I thought Kaggle seems complicated. Wow, there are so many Kagglers who are better than me. I have no chance to compete. Let me not waste time on Kaggle. Let me keep my self-esteem. Let's not submit anything, because if you're doing self, it might hurt my self-esteem. This is called self-handicapped behavior. And I actually stopped Kaggling for 7 years. So yeah, I spent 2-3 hours on Kaggle, decided this is not really useful, and I stopped Kaggling. And this is obviously not what I want to tell you today in my presentation as kind of learning. So please forget what I said here. But I think this is something that a lot of people who first try out Kaggle experience, that it is quite overwhelming. Probably they are not doing so well. This can be discouraging, but the important aspect is that Kaggle is so much more. And we will go through a lot of these things, but it is mostly about learning and improving yourself. So yeah, I decided to stop Kaggling, do my PhD, do my postdoc. Probably this was not a bad decision, because yeah, Kaggle also needs time. But I think Kaggle has a lot of advantages that we will talk about. So, and then we need to jump 7 years to 2 years ago. So actually, after this time, I finished my PhD, I finished my postdoc. I decided to go away from academia and go into industry. I started working as a data scientist in an insurance company in Austria. And in this insurance company, I worked in a team with Dimitri, who is known as Dot on Kaggle. And we had some NLP problems in our company to solve. And what we were mostly familiar with was a classical TF-IDF, count vectorizer, and then fitting, and then some kind of gradient boosting on top, or even some simpler models like naive Bayes or similar things. So we thought, okay, maybe let's look into the state of the art of NLP. And it was kind of 2 years ago, or close to 2.5 years ago, was kind of the starting area of this whole NLP trend that was coming up in the research. So it started like with like CNN-based models, and then went into like OMFIT, BERT-based models, and so on. So this was kind of the start. And we wanted to take a look into the state of the art in order to maybe also apply it to work. And Dimitri was before already participating on Kaggle in 2-3 competitions. And he suggested that we look at some Kaggle competitions in order to improve our skills. And yeah, lucky to us, there was a NLP competition, which was the Quora Insincere Question Classification. And we decided, okay, let's spend some time at work on this competition to learn without any other expectations. So we looked at it. It was about, the goal was to fit models that predict whether a question on Quora, Quora is this question answering system, is sincere or insincere. So to give you some examples here, these were actual samples from the data. And one question was, how can I become a data scientist? This was a sincere question, and we needed to predict that this is sincere. But there are more like funny or weird questions, like how come Trump is so stupid? Or is it possible for a vegan who does CrossFit to go 10 minutes without telling someone about it? Or every time I slap myself in the face, it hurts. How can I prevent this? So obviously very insincere questions. And the goal of Quora, of course, is to filter these out and not display them on the website. And this was basically the task we were trying to tackle in this competition. It was quite of an interesting setting in the competition. And this was, I think, the last time that the setting was like this. And so you had to train your models in the Kaggle environment, so in the Kaggle notebooks. and also do the prediction. Nowadays, it is mostly that you do your model fitting outside and then only have to do the predictions within Kaggle. But at this, we also had to fit our models. And for us, this was really great because we didn't have any hardware externally. So everyone had kind of the same environments that he or she could work in. And we were put at least at common level of other participants in that sense. And also this was interesting is that no external data was allowed and there were only pre-trained embeddings for the data given. So there were graph embeddings, paragram embeddings. So it was already kind of out of the scope to train some of the upcoming super new NLP methods like OMFIT and so on. BERT was, I think, not even out at that point. But rather you had to come up with your own structure. And for us, this was great because we could get into deep learning and neural networks. We had little to no experience on that before. And we had to design our network ourselves. And this is kind of our solution. And to me now, this looks rather simple, but very elegant. And I really like elegant solutions. So it was just, you have for the text, you have the embeddings given. And then you have a bidirectional LSTM layer on top of these embeddings for a given sentence. We also put in some statistical features, and then you have a head. So how you would solve this problem nowadays is that you fit this data into Hugging Face, have a BERT-based model, change the output layer and out. And actually, someone tried one year ago, and also some colleagues of mine tried to solve this competition now with BERT, and BERT is better, yeah, but it is not so much better that you would say, wow. And this is really telling to me that also like rather simple solutions can be really, really good. And yeah, I'm talking about the solution, but to talk how we ended, we won this competition. So yeah, this was kind of perplexing to us because we went into this competition to learn about state of the art and learn about deep learning and NLP, and we ended up winning. So we kind of, yeah, it was perplexing to us, and it kind of started obviously my real journey on Kaggle. So I would say this was like Christmas around Christmas 2 years ago. This started really my journey on Kaggle. You can also see some other Japanese Kagglers here. Guanshu is currently very close to me on second place. Already did very well here. We also jumped, like most of you are familiar, there is a public leaderboard always and a private leaderboard. You only see the score of the private leaderboard at the end. And we jumped 3 spots here. So we had a very robust solution. So this kind of told us already that we know how to fit machine learning models. So what were my learnings from this competition? Wow, I'm capable of competing on Kaggle. Kaggle is actually fun. I can learn so much new stuff, and which was to me always also a problem in academia, is that it was hard to apply what we research on real data sets and problems. And on Kaggle, you have real data sets, you have real problems, because there are people behind these competitions, and to them, this task is important. So that's why they put it on Kaggle and let people try to figure it out. Yeah, it also pathed it was a new path for me to go in terms of working with neural networks. I was mostly focusing on classical machine learning techniques before, and I found out neural networks are awesome and flexible, and I can do a lot of stuff with it. Obviously, also the community on Kaggle is great, and yeah, so my journey started. What followed is, I will not go too much into detail here, but what followed from bottom to top were kind of the next competitions I did, where like, I always had this goal, and this is kind of a whole theme around my presentation, is to always look at new and different types of problems. I don't think it's too important or even beneficial if you say like, oh, my specialty is image classification for X-rays, and I only do these competitions. I think it is very important for yourself to always try to go into problems you have little experience, and you will see that if you have general machine learning knowledge, or even if not, you will learn a lot of new things. And for me personally, it is always important to work on a problem while I'm trying to learn something. I can read 3 books and get way less out than if I would just pick the problem and learn along the way. So I know people are different, but for me, this works very, very well. And it allows me to extend my repertoire of tools and methods I know. And there is a lot of interconnection even between different types of problems where you can apply different techniques. People think that computer vision and NLP and tabular data is so different. Of course it is different, but there are a lot of similarities between them. Like in each of them, you need to know how to do proper validation and proper setup of the experiments. In all competitions, you need to look at the data. In all competitions, you need to do hyperparameter tuning. So there are a lot of commonalities and sometimes even techniques from one type go into the other. Think about transformers being originally for NLP and now they are all over the place. Yeah, so I started to look here into tabular competition. I won a competition with a very large team on earthquake prediction. I also jumped into computer vision, was also very excited to do well here because this is also something never did before. Did something on fraud detection, again, tabular time series like data a little bit. Then I actually went to Kaggle days in Tokyo. I was very fortunate that I had the opportunity to go there. Maybe I met some of you in the audience. And yeah, also participated there in the hackathon with some Japanese colleagues. And yeah, so really I was super into Kaggle at this point. I was doing well on all types of competitions. And then I continued to participate, of course. The next competition, I want to talk a little bit. Yeah, so maybe before I switch to the next competition, some more learnings, which is something that is very close to my heart, is that I really enjoyed teaming. I teamed with, already in this short time span, I got into touch with so many different people. And I really enjoyed it and I got so much out of it because you can learn from others, ideas, methods, tools, approaches. You can have more fun, in my experience. You can build connections, you're not alone. But teaming also requires commitment and a kind of etiquette. So finding good teammates is hard. Obviously, the more successful you are, the easier it is to find good teammates because people are more likely to want to team with you. But that doesn't mean you cannot find good teammates if you're not doing so well, and just learn from each other. And learning in a team, to me, is also something that I really enjoy. In a team, you need to communicate a lot. You need to be honest. It is not a good experience if you go into teaming and you tell the other person, oh, I will work on this problem 12 hours a day, and then you go silent. This will not be beneficial for anyone. I personally also prefer early teaming versus late teaming. Like late teaming is a thing on Kaggle where you just team in order to blend different solutions. But I don't think there's too much value to get out of it, except maybe a little bit better position on the leaderboard. And if you start to team early, you can really improve your team experience. And what I said is to learn along the way. One of my favorite teams I ever worked with was obviously with Dimitri. We were called the Sioux. So our team name was the Sioux. And the first competition we really decided to tackle just the two of us was the NFL Big Data Bowl competition. And I think at this point, still this competition is my favorite one I ever participated on because also what I got out of it. So the goal in this competition is that these players have sensor pads in their sensors in their shoulder pads. And in this play that you can see on the left-hand side, we had the sensor data available at the time of handoff. So here, yeah, the ball is passed or given to the rusher. And at this point, we had the sensor data. So we had the position of all the players. We had the acceleration, the speed, and so on and so forth. And we needed to predict how far the player is rushing, to give a probability distribution of how far the player is rushing. Is it like 10 yards, 40 yards, most likely 3 yards? So we had to predict this. And here I want to start with the results. This is our personal bragging slide, because we did so well in this competition. We had like a huge difference to the other teams. And this was also a very unique competition in how it was evaluated. So it was evaluated on live data. So you had to provide the model, and it was doing then the predictions on a weekly basis regularly on the actual live games of the NFL. So you had no way to peek into the test data at all while training the models. It was completely unseen data that you had to predict. And in this competition, we really had perfect CV, public LP, and then also private LP correlation. I think this is something I will never see again. Yeah, so not too much time to talk about the solution, but I want to give you the quintessence of it. So we had this position of the players, of offensive and defensive players, and obviously the rusher. And these players were unordered. So what we did is that we have kind of a 3D tensor where you have like on one dimension the offensive players, on the other the defensive players, and on the third dimension some features, which are mostly relative features between the players. So you have like, what is the position difference from this player, from this offensive player to this defensive player, or the speed difference, or also for the rusher, it was like, what is the difference between the rusher and the defensive players? And as you have an unordered set, what we did is that we built a custom neural network that is mostly based on rather simple one-dimensional convolutions and then poolings. So first you run some convolutions on this tensor, and then you pool across, you assess each defensive against each offensive, and then you aggregate. So in the first step, you get some kind of average estimate of each defensive player. And then you have another step where you assess the rusher against each defensive. So first defensive versus offensive, and then rusher against defensive. And then you get kind of an estimate of how high the chance is for the rusher to run far or not far. And you have a hat and you predict the yards in a kind of probability distribution. And this really is state of the art that we built ourselves for these types of problems. And it can also be applied to very similar problems. And what is really exciting about this is, I want to start with the last point here, is that the hosts actually put this model into production. So what you can see here on the right-hand side is from live national TV in the US of an NFL game this season. And they have these rush yards over expected, which is actually exactly our model that we implemented. They re-implemented it and put it into production, and it is used in live TV and in internal analytics purposes. So this is like, I think this is kind of the biggest honor that you can ever have with building machine learning models, is either that they are put into production in your company where you work for, or you make tools that others can use, or in this case, even Kaggle hosts are eager sometimes to put these into production and you produce value. So this is kind of the biggest honor, in my personal opinion, that you can get. Other learnings, yeah, we also went to the US to kind of an NFL event to present our solution. Other people are building on it. So in a sense, this was a really rewarding competition for us. As I mentioned, we had perfect CV and LP correlation. Another important learning for me in this competition was this, that you need to spend time, and many iterations and experiments are important. So on the top hand right, you can see kind of a graph of our experiments. And for example, sometimes the green path goes into the direction where we tried something in a certain direction and it didn't work out and we had to go back to the main branch. And the real challenge in Kaggle competitions is that you go from your baseline model at the beginning to kind of your robust end solution at the end. And you're not lost along the way, along a wrong path in a way, but rather follow the main path and get to a good solution. So this is kind of placative example. So, but it isn't something important to note. Yeah, so you need to experiment a lot. You need to know how to run experiments. You need to make valuable conclusions about certain experiments, if something is better than the other and which direction to go. And this is something that is also a lot of experience that you learn along the way. And yeah, simple solutions can be beautiful. And yeah, building hard models, building complex models is easy, and building simple models is hard. I think Guangzhou has that in his profile. I think it is really, really an important phrase and something that I really love to cherish. What followed were some more deep learning based competitions. Then COVID hit. I actually joined H2O at this point. We are also always trying to do data science for good. So for us, it was kind of natural to also participate in these COVID forecasting competitions. And across them, we did really well. The last one, for example, second place. So this was really also something that was not so much about doing Kaggle stuff, but rather about trying to build good models that might help to forecast the pandemic. After that, I was actually still not a Kaggle Grandmaster. So I think I was at position 6 or something in a global leaderboard, but I was still not a Kaggle Grandmaster. So I had, for myself, I wanted to also go solo and get the gold medal. And I decided to join 2 competitions at the same time, 2 NLP competitions. One was the tweet sentiment extraction competition I want to talk about, and the second one was jigsaw competition. In this tweet sentiment extraction competition, we were given tweets. So for example, my tweet could be, wow, I finally managed to get to rank 1 on global leaderboard. And then we knew the sentiment, which would be positive in this case. And then we had to automatically extract the positive part of this tweet, which could be, for example, wow, yeah, or awesome, if I would have started with that. And people were manually labeling these tweets, and we had to automatically extract that. And obviously, at this point, people were using BERT-based solutions. So my solution was Roberta-based, which is a version of BERT, using the awesome library Hugging Face. And kind of the trick here, or not trick, but important part of my solution was to change the tokenizer in a way that it better adheres to the data. And I also employed what is known as knowledge distillation. So you try to combine several of your models to single one in order to reduce also the runtime of your final submission, and also to, yeah, it's kind of blending on a model way. There was a small leak in the competition. I did not find it. I could have done better even with it. But unfortunately, there was a small leak. Usually I'm good at finding these, but in this case, I was not able to. Yeah, but still, I managed my solo gold here in the first competition. I really attempted to do solo, and this made me competition grandmaster. This was very important to me because I also kind of showed I can do it on my own. Actually, at the same time in this other competition, in the jigsaw competition, I also got solo gold. So yeah, I did it in both. So what were the learnings here? I can do it alone, as mentioned, but solo has advantages and disadvantages. I think one advantage is what I also mentioned earlier is you're just responsible for yourself. You don't owe anyone anything. So if I decide to ditch a competition, if I'm playing alone, I can just, yeah, I'm not impacting anyone else. So yeah, I can make my own decisions. But it also has many disadvantages. Like I felt a bit like on the image on the right, very alone, just thinking about the problem alone, not having anyone to talk about. To me, this is usually important. I just try to put my thoughts out, and maybe someone catches them up, and we make better sense out of it. Other learnings is that pre-processing is also important in NLP. That was shown that the tokenizer has impact. And yeah, Hugging Face is awesome. You can build really good solutions with it. Want to talk about 2 more competitions. One of them is Google Landmark Recognition, and this kind of started another part of my Kaggle journey. So the first was like getting into Kaggle, learning a lot of things, teaming with very clever people, the Sioux doing very well in this NFL competition. Then I did my solo gold. So this was kind of the solo part. And now I really tried to perfectionize some of the material I'm working with. So before that, I was mostly like working on random Jupyter notebooks. Also, the teamwork was kind of messy, and I will talk about this here, but here I really tried to perfectionize this. This was, I teamed here with Christoph, known as Dieter on Kaggle, just us two. And the goal was to predict for a given landmark image, the landmark. And this was a really large scale data set with like millions of images and more than 200,000 classes. So just fitting a binary cross entropy loss on that, and it works, but it is not enough to get really good results. So what you need to do here is that you go into metric learning, and there is another loss, which is the arc phase loss, and this loss tries to optimize the embedding output of the neural network, and more similar images have more similar embeddings, and then you can run some similarity metric on the embeddings to get good estimates about what are similar images, and then use this either for recognition or also retrieval. Yeah, on the bottom you can see our network. It is not too complex, but you have some image backbone, in this case, for example, Sarah's next, some pooling, some neck, and then you get this image embedding, and you have the arc phase loss in the end. And then you take this image embedding, 512 dimensions in this case, and you do Gaussian similarity between images in order to detect the similar ones. There was also some post-processing involved, but I want to mostly talk about really the technological aspects of this work. So this was the first work where we also openly published our code. There was a paper involved that we wrote. So it was really clean code that everyone can run. And we reuse parts of our code that we started here in all the competitions forward, and we perfectionized that along the way. Yeah, we won this competition, also with quite a margin in the end, beating Best Fitting. This is always exciting because he's one of the best Kagglers of all time. And as I mentioned, we started to work better in a team. And from this point on, I teamed a lot with Christoph and also Pascal, and we have a very good pipeline of how we work together. And this boosted our performance even more and our efficiency. So as I said before, I was mostly doing like random notebook sharing, CSVs within Slack. But here we started to build like a common code base on GitHub and work in branches for new features, make pull requests, use config files, put the data set on Kaggle, and it is also easier to share at the end. We also started to better share the predictions and the data we produce throughout the competition. So before, as I said, put it on Slack, share the CSV. Here we started to use, for example, S3. So we generate a bucket at the beginning of the competition. Everyone pushes the result to the bucket, and then everyone can pick it up and do something with it, for example, for blending. And what is also very important is logging. So in deep learning specifically, this is incredibly important, is that you start to track your experiments in order to make better decisions about your experiments, like the graph I showed before. And this, in a team, this also allows you to compare between teammates' experiments. So we, for example, use Neptune AI a lot. And here you can see, for example, Christoph and me ran a lot of some experiments, in this case, the lift competition. And then I can just click compare for 2 experiments. And I can see here, this is, for example, the competition metric, how one experiment versus the other one is doing. Yeah, I can plot the train loss, learning rate, and any other kind of metric you're interested in. And this can really help you to make informed decisions about the experiments and the models you choose. So this is really, really important. as time is a bit short, I will try to skip over this a little bit. But in the end, the final competition I want to talk about is the Rainforest Competition, which was an audio competition. And we went into, Pascal, Christoph, and me went into this competition, again, without many expectations, because first of all, there was already very high leaderboard score. So we had to catch up a lot. And it was about audio, which we haven't been doing before. So you had like these audio clips, and you needed to predict the presence of birds and frogs within this 60-second audio clip. But it was very interesting in a sense that for the training data, we only had partial labels given for each audio clip. So for example, you just knew from time 50 seconds to 55 seconds was bird 1. But it doesn't mean that bird 3 was not part of the 60-second clip, but for test, we had to predict the whole 60-second clip. So there was a lot involved in terms of trying to work with partial labels, with so-called hard and weak label models. And there was some involvement of pseudotagging. We had to do a lot of blends also and adjust some species. But the real trick was that if you have the spectrogram, so that's how audio works nowadays, you build a spectrogram, log spectrogram of the audio clip and then feed it into an image classifier, is that you split, in this case, we only knew, for example, at certain periods, what the labels are. And you mask out the other parts of the clip and only calculate the loss at certain periods in time. And so you don't learn on labels you don't have. So this was really, really interesting competition in that sense. I'm cherry picking, of course, the competitions I have been doing well. So we won this competition, and this was really unexpected, as I said, because Selim already had a very high score very early on, and he also did very well in the end. But this was, in two sense, unexpected, because this was also then the competition that allowed me to achieve rank number 1, and this was definitely not expected in that one. So learnings on this one is that high public scores can be beaten. Sometimes public LB is the best validation fault. In this case, this was really the case because test was so different to train, so it was very hard to find a good validation setup. I'm a bit careful to put this on the slide because this is usually bad advice that you overfit on public LB, but it is important for you to figure out when you need to overfit to the public LB, because this is your best validation fault. Semi-supervised learning can work. It is something I have been a bit critical. I'm not the biggest fan of pseudo-tagging, but in this case, it worked really well. And yeah, another learning, something I would have never expected, is that I managed to get to global 1. Yeah, so I have given you a rough overview of my journey. Of course, there's a lot more to cover. I tried to provide you with some of the more meta learnings I have on the competition, on different competitions. And on this slide, I want to summarize a few of the key learnings. So I think the first one is very important to keep close to your heart, is that Kaggle is a place to learn, develop your own skills and stay up to date. This was my original intention when going to Kaggle. And I have to keep this in my mind also nowadays, because you can get very competitive and you can go like, oh, this competition, but this is kind of the core of Kaggle. But the competitive spirit can push me forward. I think if I would do this project just for myself without any competitive spirit, I would stop at like the 80 or 90%. But really pushing to the boundary of what you know and what the scores are can leap away your knowledge quite heavily. So for me, this competitive spirit is quite important. Not everyone is like that, but you need to find your own way of how you can strive. Finding good teammates can be very rewarding. Like, this is very important to me. I have met a lot of good friends now on Kaggle. So this is yeah, the best thing is what happens along the journey and what kind of people and things you learn. People you meet and things you learn. Try to have fun, just do it. Don't be afraid like I was probably 9 years ago. Even if you're not doing well, this is not a problem. Like, whatever, you learned new stuff. And there are many Kagglers who have started out with really little knowledge and have come a long way. Yeah, some more technical things. Understanding the problem and data and finding good validation sets that can generalize well to unseen data is crucial. And I think this is probably one of the main things you learn on Kaggle, and which is so important in any kind of job and data science activities you do. There is so much wrongdoing of how people validate their models and how people think they have good models, but they're just overfitting. And then put them into production in their company. So I think on Kaggle, this is one thing that everyone can learn, really everyone, and which is very important for any kind of data science activity you do. To me personally, tackling problems I had very little experience was the most rewarding aspect, because even if you don't do that well, you can still learn a lot. And there is also so much overlap, I feel like, between different types of competitions. So for example, in the NFL competition I showed, other types of solutions were mostly like graph-based, transformer-based solutions. And people did a molecular link prediction competition before. So a solution from molecules was working very well for a competition with NFL data. This is just mind-blowing to me. And you can only open up this perspective if you do different types of problems. And then you might find pieces that you can puzzle together. Yeah, you need to build up a repertoire of methods and techniques. This is what I just mentioned. And you need to, the larger your repertoire or array of methods is, the more flexible you are in your solutions. And what is also very important to me is what I tried to cover a bit at the end of this competition, of this talk, is that engineering is very important and is an integral part of a good data scientist. So engineering, writing good code that runs fast, that you build a good code base, that you even know, this is not so important on Kaggle, but also a little bit, how to put this into production, how to do fast inference, because if you have a kernel competition, you are limited in kind of how many models you can include. So all this, how to do the logging, how to do the data wrangling. So all these are engineering parts that are also important on Kaggle. Yeah, and I also want to thank all my teammates. I hope I did not forget anyone on this slide. Please excuse me for that. But like the main people is Dimitri, Christoph, and Pascal, and also H2O, they have given me kind of the environment also to manage to get to ranked 1, and obviously all the other people I have teamed with, Kaggle admins, Kaggle, all other Kaggle community. So to me, this has been a very exciting journey, which is hopefully not at its end. I will not stay forever ranked 1, but this is fine. I mean, I have achieved something great here, and it gives me even more motivation to go further. Yeah, so thanks for listening, and